and today I'm gonna teach you a little bit about the layers of Earth's atmosphere. And so I made some notes out of so I've been researching on Google about the Earth's atmosphere, and I copied down some notes so I could use them to record this video. So I'm gonna teach you guys a little bit about layers of Earth's atmosphere. So here we go. Starting off the introduction, Earth's atmosphere has a series of layers, each with its own specific traits. Moving upward from ground level, these layers are named troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The exosphere gradually fades away into the realm of interplanetary space. Okay, so the first one is troposphere. So we're going to read troposphere first. So, troposphere. The troposphere is the lowest layer of our atmosphere, starting at ground level. It extends upward to about 10 kilometers, 6.2 miles, or about 33,000 feet above sea level. We humans live in the troposphere, so like our houses, buildings, us, cars, everything that's literally laying on the floor is in the troposphere, and nearly all weather occurs in this lowest layer. Most clouds appear here, mainly because 99% of the water vapor in the atmosphere is found in the troposphere. Air pressure drops and temperature gets colder as you climb higher in the troposphere. So, stratosphere, next one. So the troposphere, that was the troposphere, and it talks about the troposphere. And as we know, main point is that we live in the troposphere. Stratosphere. The next layer up is called the stratosphere. The stratosphere extends from the top of the troposphere and to about 50 kilometers, 31 miles off the ground. And the infamous ozone layer is found within the stratosphere. Ozone molecules are in this layer absorb high energy ultraviolet UV light from the sun, converting the UV energy into heat. So that's why the stratosphere is very hot, very very hot. The top of the layer of the stratosphere is very hot, and the this layer protects us from the ultraviolet rays from the sun, which could give you sunburns and harm your skin. But the stratosphere is still protecting a little bit of it. So when you go to the beach, sometimes you wear sunscreen because of the ultraviolet rays. They might come on you and burn your skin, or you might get sunburn. So that's why stratosphere protects us, but it doesn't protect us literally the whole time. It just protects us as much as it can, because you can still get sunburn if you're still out without sunscreen. So sunscreen also helps a little bit, but you could still get sunburn. But the stratosphere, it helps a lot. So, unlike the troposphere, the stratosphere actually gets warmer the higher you go. That trend of rising temperature with altitude means that air in the stratosphere lacks the turbulence and updrafts of the troposphere beneath. Commercial passenger jets fly in the lower stratosphere partly because this less turbulent layer provides a smoother ride. The jet stream flows near the border between the troposphere and the stratosphere. Okay, so that little part I'm gonna explain to you. Most planes, jets, they all go under the stratosphere, especially because of smoother rides. And also, so when it says the jet stream flows near the border between the troposphere and the stratosphere, I wrote that down because the planes, what happens is that the jet streams boost. It helps planes go faster, so they travel faster, and it helps pilots a lot to get to their destination faster, because half the time you're mostly only planes only use fuel. But when you could reduce using that fuel, like, so let's say planes are using more fuel to go more faster to their destination, but you could use less fuel this time than you used before, because when you're in the jet stream, the push is very high, so it would actually help you a lot, and it helps planes a lot smoothing. I mean, not smoothing. Sorry. It helps planes a lot, flying a lot easier. Okay. Next sphere is the mesosphere. So the mesosphere is right above the stratosphere, and the mesosphere, really, I think the mesosphere is the third sphere in the atmosphere. So here you go, the mesosphere. Above the stratosphere is the mesosphere, like I said. It extends upward to a height about 85 kilometers, approximately 53 miles, above our planet. Most meteors burn up in this layer because, so let's say if you're seeing like shooting stars and stuff, they're not really shooting stars, they're actually meteors burning up. And that trail of light coming behind it is that fire-ish type of thing that burns up behind the meteor because of the speed and the pressure impacting on each other. So most meteors burn up in this mesosphere. Unlike the stratosphere, temperatures once again grow colder as we rise up to the mesosphere. The coldest temperatures in Earth's atmosphere is about negative 90 Celsius, negative 90 degrees Celsius, which is apparently negative 130 feet. Sorry, my bad. Negative 130 feet Fahrenheit, degrees Fahrenheit, and are found near the top of this layer. The air in the mesosphere is far too thin to breathe. Air pressure at the bottom of the layer is also well below 1% of the pressure at the sea level and continues dropping as you go higher. And the next one is the thermosphere, and thermosphere is actually the second to last, because actually usually it's the last one, or the exosphere is the last one. But it's the thing is that most people don't include exosphere and ionosphere. I'm gonna include those two too, because those are really important too. It's not those all of this stuff includes up. It's like they all make the atmosphere. So like the exosphere and the ionosphere, mostly the let's see. So the troposphere, the stratosphere, the mesosphere, and the thermosphere are mostly the main parts of the atmosphere. But they add the exosphere and the ionosphere. The ionosphere, so it's like so exosphere is kind of important. I mean, they include that, but ionosphere is the most like the thing that they don't include a lot of times when you're studying. Like teachers don't really include that a lot. Well, that's because if you take it like it's like the planets, how the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, like that. But then at the end, there is Pluto. Pluto is like a dwarf planet, right? Like that, Pluto is not really recognized a lot in the planets, but the ionosphere is pretty much just like that. So yeah. Okay, so here we go. Thermosphere. So the thermosphere, the layer of a very rare air above the mesosphere is called thermosphere. High energy X rays and UV radiation from the sun are absorbed in the thermosphere, raising its temperature to 100 or at times thousands of degrees. So, pretty much, it's like storage. It's like a storage room. The sun keeps on. So, the sun keeps on sending UV rays and energy rays to Earth. The thermosphere gathers that up because too much heat for us is not good for humans and life. Any type of life, too much heat is not good. It has to be the right amount. So, so they absorb and like so. For example, let me see. An example is storage room. Let's say you have a storage room or a storage bunker. You guys rent it. So let's say someone. Okay, let's say someone rented a storage room, like a storage like garage or something like that. And okay, what they do is when they have too much like supplies in their house that they don't really need, they put it in the storage room. So the more supplies you don't need, the more full the storage room gets. So it's like they keep on putting storage room supplies, keep on putting storage supply. It gets compact and it becomes very full. Sometimes storage room can't hold that much things. So what the thermosphere does is the thermosphere is like the storage room. It holds all that heat in, and it only lets a little bit of heat out. That's good enough for humans. So that's why the thermosphere is very important. It's like the storage room. Like lots of people, let's say you don't need something and you really, so let's say you don't need something, you throw it in the storage room. You want something from the storage room it's like old and like fancy and stuff, you bring it back into your house. It's like that. So it's kind of like that. I mean, It's the closest thing I could get to as an example, but yeah. So where are we? So many satellites actually orbit Earth within the thermosphere, and variations in the amount of energy coming from the sun exert a powerful influence on both the height of the top of this layer and the temperature within it. Because of this, the top of the thermosphere can be found anywhere between 500 to 1,000 kilometers, which is 311 to 621 miles above the ground. Temperatures in these in the upper thermosphere can range about from about from about like 500 degrees Celsius, which is approximately 932 degrees Fahrenheit. Sorry, to 2000 degrees Celsius, which is 3632 degrees Fahrenheit. That is way too much. Humans, possibly physically and most mentally, cannot live there. One step in that layer, humans dead. That's how it works. Because the heat, I'm pretty sure humans could only live in heat that is, I think, approximately like over 110 degrees. I don't know the exact number, but I'm thinking it's somewhere close to 110 degrees. If it passes 110 degrees, it's not really good for you. And then it goes to 200. Most likely, you're not going to live as long. And then, see, it only take 200. Look at this big number. It's 3,632, which is a lot. And I'm not talking like I'm talking Fahrenheit, not Celsius, but Fahrenheit. So it's very hot, not good for humans to live in. Okay. So last line to end off the thermosphere. I wrote that the aurora. I like this part what I wrote the because the well because the aurora, the northern lights and southern lights occur in the thermosphere because you know those they look like swirls of lights in sky. It looks very weird but then cool at the same time. Well, like those lights. So those are called the northern lights and the southern lights. They occur in the thermosphere. Mostly they're called northern lights. Some of the people call them a southern light. Sometimes they're in the southern part of the world, but they're mostly called auroras. Either one, either it's the northern lights or the southern lights. Those type of lights are called auroras. They happen around the world. Not as popular, but I mean I wouldn't say rare, but I wouldn't say it's popular either. So okay, so we finished with the thermosphere, and now I'm going to go to the exosphere. Exosphere and ionosphere. So, exosphere first, and then the ionosphere. So, so this is all. I wrote a lot. I'm sorry if I'm making you guys wait, but this is pretty much everything I know about the layers of the atmosphere. And just before I continue, I wanna give a credit to science.ucar.edu. It's the website. It's an education website, and it helped me a lot. It helped me a lot write down my notes for the what to call it, the layers of the Earth's atmosphere. So it's very important. I want to give credit to that. I don't want to take everything because they did help me a lot. Mostly I used only this website. I used some other websites like Britannica and stuff. So yeah. Okay, continuing. So exosphere. Although some experts consider the thermosphere to be the uppermost layer of our atmosphere, others consider the exosphere to be the actual final frontier of Earth's gaseous envelope. So exosphere, just a heads up that it goes from on top of the thermosphere and it's pretty much just goes into space. No one really knows the exact distance, but mostly it just goes into outer space. Okay, so as you might imagine, the air in the exosphere is very, very, very thin. It's very thin, making this layer even more space like than the thermosphere. In fact, air in the exosphere is constantly through very gradually leaking out of Earth's atmosphere into outer space. There's no clear cut upper boundary where the exosphere finally fades away into space. Different definitions place the top of the exosphere somewhere between 100,000 kilometers, which is 62,000 miles, and 190,000 kilometers, which is approximately 120,000 miles, which is a lot, like a lot above the surface of Earth. So the latter value is about halfway to the moon. That's surprising because first of all, half of the moon, the distance from Earth to the moon is over like so let's see. So if it's 120 miles, it's about like 250,000 miles, 260,000 miles. So highest probably like 275,000 miles. And if it's half, that's a lot because it's just a lot. I mean, that's a very great amount. So the latter value is about halfway to the moon, and that's pretty much it for the exosphere. The exosphere main point, it's very big. The experts and others consider this as a final layer of the final layer of the Earth's atmosphere. Some people think it's thermosphere, but experts say it's the exosphere. And that's one point. The other point is that it's halfway. It's the latter value is halfway from the moon, and it's literally just spreads out into space after the thermosphere. Okay, so the last sphere is ionosphere. Ionosphere, I was saying that was like a dwarf planet. It was like Pluto because not a lot of people recognize it, or not a lot of people use it. And the ionosphere is not a distinct layer like other mentioned above. Instead, the ionosphere is a series of regions in part of the mesosphere and the thermosphere where the high energy radiation from the sun has knocked electrons loose from their parent atoms or molecules. Like, so molecules and the atoms are pretty much scattered. So so what is this saying is it's high radiation, the from the sun's high radiation is knocking pretty much and scattering the molecules and the electrons from their parent atoms. Like, so for example, let me take this example. Let's like split it. Splitting, so atoms, so let's say parent atoms are right here, two parent atoms, okay, two parent atoms, two other atoms. What the sun's radiation, the high radiation is doing, it's splitting those atoms and they scatter. And then like that, this is only like one combination. This is one combination. There's trillions, quadrillions of atoms in the air. And those are all just splitting and scattering. And it's not just atoms, but it's also air molecules. It's molecules, and so okay, the molecules are doing the same thing. See, they're splitting. Okay, so see the electrically charged atoms and molecules that are formed in this way are called ions, which is giving the name of ionosphere. They call it that because of like I said, the electrically charged atoms and molecules are called ions. They use ions in very cool movies like uh, Radiation and stuff like that. I People use it, and like the first movie I could think of is Godzilla: The King of Monsters. That's one of the movies, and yeah. So those are called ions, giving the ionosphere its name, and knowing this region with some special properties. Um, I've been talking for nearly 19 minutes now, and that's pretty much all of the layers of Earth's atmosphere. That's all I know. That's pretty much the main things that you have to learn about. Also, I'm giving credit to Science UCAR Education. It helped me a lot in making this. So yeah, so this is pretty much all the layers. And like I said, troposphere to thermosphere. It's like the main layers. Exosphere, scientists say that it's the final layer, and the ionosphere is like a helpful layer that's like Pluto, dwarf planet. Not a lot of scientists use it. So yeah, so pretty much this is literally all of Earth's atmosphere. Thanks for watching, and bye.